Hello, my name is Mario Sanchez, and I'm here to present you our work, which is called a feedback-oriented platform for deliberate programming practice. This is a work that we have prepared together with Pedro Salazar, and we both come from the Universidad de los Andes in Bogota, in Colombia. So the content of my presentation is going to be the following. First, I'm going to start with some context for this project. Then I'm going to present our platform, which is called Zenecode, and I'm going to explain how Zenecode is different from other programming practice platforms. And then I'm going to show you some details about how it has been used in our programming course. Then I'm going to present just a single slide with some technical aspects of the solution. And finally, I'm going to present a small demo of the tool. The context for this work is our new CS1 course. This is a course for around 950 students per semester, mostly coming from the engineering and science schools. Typically, we have groups of 25, 26 students, and this means that each semester we have around 38 to 40 groups following the course. In this course, we have moved away from Java to Python. We are trying to focus more on the algorithmic part, and we are steering away from object-oriented programming for now in this course. In the context of this course, then we developed this platform, which is called Zenecode, which is a platform to automatically grade Python programs, which shares many similarities with other existing platforms. However, Zenecode has important differences with existing platforms. The most important one is that this platform was designed to address deliberate practice. This means that we wanted to give students as much feedback as we could, and we wanted to give that feedback immediately, and we wanted to help them to fix their own errors. So that means, for example, that instead of giving them a right or wrong answer, we suggest them ways to fix their code somehow, and we also allow them to submit many times for the same problem until they get it right. The problems that students have to solve in the platform are designed to practice particular concepts and develop particular skills. They are also classified by difficulty, and they are used both in homeworks where problems are selected by the instructor, or they are also used in a free practice way. That means that students decide which problems to tackle, and they try to solve more complex problems each time. Now, these are some numbers that show the usage of the platform. First, we see that it takes students multiple attempts to solve the problems. For us, this means that the platform is guiding them towards the right solution, as we expected. Then, we see that most students have either a perfect score or a null score on homework assignments. This is also very positive for us because it shows that the students that actually bother with the assignments eventually complete them. On the right-hand side of the slide, we have some visualizations that are available for instructors to see the performance of their classes. These are useful to see, for example, how much are students working and how long it is taking them to solve each assignment. Also to see what are the hardest topics for the class and for individual students. And also to see what tests in each problem are giving students the most problems. From a technical point of view, I wanted to make a few comments about the requirements behind Zenecode's design. First of all, we wanted to give feedback as quick as possible and do so in a flexible way. This means that in the future we will be able to support new ways to calculate feedback, such as using artificial intelligence or making stylistic suggestions. Then we were concerned with security and stability. We didn't want malicious or just wrong code to break the platform. Finally, we needed a scalable platform capable of handling more than 1,000 students per semester. We have achieved these objectives using an architecture based on Docker containers, which can grow as needed and currently takes around 18 seconds to give an answer after a student makes a submission. Now I want you to see the platform at work. This is the main screen of the platform, and I'm going to log in as a student. Here, this is my homepage, and now and here I can see what the homeworks I have assigned, or I can also go and navigate the different problems that are available on the platform. I'm going to select now one particular problem. Here there's a statement of the problem, and here there's the specification of the function that I have to implement in order to solve the problem. Here I'm going to ask to submit a new solution for this problem, and this is my current solution. I'm going to make the submission. This is a syntax check that happens immediately to see that everything is valid. Now I'm submitting the solution, and here I see the submissions that I have done previously. If I go here, I can check my last submission, which I submitted just 9 seconds ago. There's still no answer, but if I reload, now I have some feedback, and I see that I've got only 50% of the test right. Here I have some information about the possible problems that I have. Now I'm going to fix my, I'm going to make a new submission. I'm going to fix my submission, which only had a very minor error. And if I go to see my submission, eventually I should see the answer. I may have to wait a few seconds more, maybe 10 seconds more. And now I have 100% of the test cases right, so my solution is working. In conclusion, we have seen that the platform achieved its objectives. We have seen that it's an effective complement to our programming course. We have seen that it's a tool that actually is useful for students to train. They do repeated attempts at the same problems until they finally solve them. We have seen many students also doing free practice, which is very valuable for us. And we have seen in general a very high engagement with the tool. In future work, we want to grow the problem bank. We want to integrate the tool better with our LMS. We are also studying some gamification elements to introduce into the tool. And we want to open the platform, but we need to make some internationalization efforts before that. And we are also working on giving more suggestions to students about the style of their code. So thank you very much for your attention, and I'll be glad to receive questions about the platform.